Hello and welcome to Unit 5, Part 3. My name is Mr. Bell and we're going to solve some systems by any method, but we're also going to make note and identify how the system was set up to be solved in the first place. On this particular slide, if you take a look at this system of equations, it's kind of set up with the intentions of graphing. How do I know that? Well, remember, to graph a line, it needs to be in y equals mx plus b form to easily graph. Notice how both of these equations are in y equals mx plus b form. However, I do see one thing that I've noticed that might deter me from actually graphing these. If you take a look at the second equation there, and notice that the y-intercept is going to be way up here at 10, and then a slope of up 3 over 1. So it might be very difficult to graph, mainly because that y-intercept is a value that's not going to land on top of my graph. That being said, I have other options to solve systems. I'm going to choose substitution in this case because of that very high y-intercept value, making it more complicated to graph. So I know that y is equal to 2x minus 5. I'm going to substitute that in place of y in my second equation. And then I am actually going to solve this for x now. We'll subtract 2x to both sides to get those on the same side. Negative 5 equals 1x, or just x plus 10. And I'll subtract 10 from both sides to isolate my x, giving me a value of negative 15 for x. Don't forget to take that x value, plug it in for x into one of your other equations. Y is equal to 2 times x minus 5. In this case, my x value is negative 15. Y equals negative 30 minus 5, giving me a y value of negative 35. And my solution would be written as negative 15 for the x value, negative 35 for the y value. Now take a look at example 2. It's not set up so much to graph because one of the equations is not in slope-intercept form, making it more challenging to graph. I also wouldn't think this system's set up to eliminate because I don't automatically have opposites on top and bottom that would cancel, remember from our elimination lesson. This one actually is set up to substitute because one of my variables is already isolated, and as a matter of fact, it's already solved for me. I know the y value of my answer is going to be 4. Let's take that y, substitute it in place of y in the first equation, and see if we can solve for x. 2x minus 5 times y equals 8, but in place of the y value, I'm going to plug in that 4. This would give me 2x minus 20 equals 8. I'm going to go ahead and add 20 to both sides to cancel it from the left, leaving me with 2x equals 28. One last step to cancel times 2 or multiplying by 2 would be to divide both sides by 2, giving me an x value of 14. And that completes my point that is a solution to this system of equations. On this last example, make note that it's not set up very easily to graph because neither equation is in slope-intercept form. It's not set up very well to substitute because I would have to do some algebra, some rearranging in order to isolate one of my variables in order to substitute in place and solve. This system is actually set up to eliminate. If you notice on top and bottom, I see a set of opposites, a 10x and a minus 10x, that will eliminate each other if I add them together. So I'm going to go ahead and add these systems and solve by elimination. 10x plus a negative 10x would eliminate. Negative 12y plus 13y is 1y, or just y. 20 plus a negative 15 is the same thing as saying 20 minus 15, which is 5. Well, there's half my answer. Don't forget to take the y value, plug it in for y into one of your original equations, and then solve it for the x value. So I'm going to rewrite that top equation as 10x minus 12 times y equals 20. In place of the y, I'm going to plug in the 5. This leaves me with 10x minus 60, I believe, equals 20. I'll cancel that minus 20 by, I'm going to cancel that minus 60 by adding 60 to both sides, leaving me with 10x is equal to 80. And then to cancel that times 10 or multiplying by 10, I'm going to divide both sides by 10. leaving me with an x value of 8, and the solution to my system is the coordinate 8, 5, x value of 8, and a y value of 5 would satisfy both of those equations. All right, thanks for watching. Hope this helps.